All right, so this word problem that we're going to work through is actually a fairly easy word problem, one where you're just given a value, plug it in, evaluate it. Should be very simple, but errors definitely happen. And so this is another situation that with a word problem, we want to picture what's going on and see what answer would make sense. So as we read through this one, the period of a pendulum is the time it takes for the pendulum to make one full back and forth swing. The formula for period P in seconds is blah, where L is the length of the pendulum in feet. Find the period of a pendulum whose length is 23 feet rounded to 2 decimal places. So let's picture 23 feet. So if we think about a normal building, wherever you're at right now in the world, if you just look up and look at the ceiling is probably between 8 and 10 feet off the ground, somewhere in that ballpark. So if we're talking about a pendulum of 23 feet, then we're talking about 2 to 3 stories. So we have a house here on the ground. Here's your door, couple windows. I'm no artist. And we have a pendulum that is as tall as this house that's going to go back and forth. If you picture these and say 1 Mississippi, 2 Mississippi, and you look outside of your house or look for a house that has 2 stories to it, and you picture that pendulum going back and forth in 2 seconds, and that thing is moving enough that it's going to slice neighborhood kids in half. Not a pleasant picture. The only reasonable answer up here is the 5 seconds when you actually start counting 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. If you're actually looking at a house that has a pendulum at the peak of that house and you picture it going back and forth, that's the only reasonable answer up there. Now, to actually solve this problem, again, this is not a super complicated problem to solve. And we can even estimate it without a calculator fairly easily. This problem is asking us to plug 23 in for the L. And that's it. So it's just a calculation on the right hand side. Now, even without a calculator, when I look at 2 pi, pi is 3.14. Let's do a ballpark figure of 3. 2 times 3 is 6. We got the square root of roughly 2/3. That's going to end up getting you something slightly bigger than 2/3 when you take the square root. So if you take something like 6 and take 2/3 of it, 2/3 of 6 is 4. We're going to have something slightly bigger because pi was actually bigger than 3, and this is actually bigger than 2/3. So we know we're going to end up with something bigger than 4, and the only thing up there bigger than 4 is 5.33. Now, the reason I want to talk about that aspect, the getting a ballpark idea without plugging into the calculator, is because that's going to help avoid some just silly errors that pop up. For instance, one error that's going to pop up in a situation like this, let me bring my calculator off to the side here. A silly error that might pop up is just to literally forget to type pi and say, I'm going to do my 2 square root 23 over 32, hit enter, and get an error. Now, luckily in this particular problem, that's actually not one of the errors that appears there, but that's an error that could pop up. And so we know that that's not the right answer. We should be doing 2 pi square root 23 over 32. And this will get us that answer of 5.33.